Hey kids, Flexing Teacher Weber here. So in the last video I showed you, we just started talking about what square roots mean. And when I say square roots, you say side length of a square, because that's what a square root is. Now what we're going to do, the focus of this unit is doing some estimating with square roots without using a calculator. But you are going to use a calculator to check it. How am I going to know if you're doing this? Well, I probably am not, except there is some work I'm going to get you to show that will tell me that you're doing some estimating. So I want to start this off with a word problem, okay? It says, Eric wants to know if a wading pool will fit in a small space in his yard. He must estimate the side length of a square wading pool, which has an area of 7 meters squared. So Eric wants to know or estimate the side length of a square wading pool. When I say side length of a square, you think to yourself, square root. So he wants to estimate the square root of a square wading pool that has an area of 7 meters squared. Now I want to draw out what this looks like first. So we've got a square wading pool, or what we think is a square wading pool. So I'm just going to draw this out like that. And it's got an area of 7 meters squared. That's the amount of space that this wading pool takes up. Now before we do anything, I just want to jump back to my perfect square table. So in all of these perfect squares, there's 1, oops, I'm going to undo that. There's 1, 4, 9, 16, 25, 36, 64, 81, 100, 121, 144, 169, 225, 256, 289, 324, 361, 400, right? If you look at all these perfect squares, what you don't see in those perfect squares is 7, right? All of these numbers that I'm outlining with that little star you see right now are perfect squares, but there's no 7 in there. 7 is not a perfect square. Now the closest perfect square to 7 is 7 lies between the perfect square 4 and the perfect square 9, right? So 7 is not a perfect square, but it's going to lie somewhere in between 4 and 9. So I'm going to go back here now. So what we're trying to do in this problem is we want to estimate the side length of this square wading pool. So we want to estimate this distance. I'm going to call it x, because it's an unknown. Now here's how we're going to estimate it. We're going to estimate it with a number line. So I'm going to draw a number line on my paper like this. Now this is really important. The top of my number line, I'm going to call squares. And the bottom of my number line, I'm going to call square roots. Okay. Now we want to estimate the square root of 7. The reason we have to estimate it is because 7 is not a perfect square, right? If we go back to this page, 7 is not a perfect square. The first perfect square is 1, the second perfect square is 4, then 9, then 16. 7 is not a perfect square. The closest perfect squares to 7 are 4 and 9, so those are really important. I'm going to go over here, and what I'm going to do at the beginning of my number line is I'm going to put the perfect square 4 here and the perfect square 9 here. Now, what I want to do is figure out where I would put 7 on this number line, because that's what I want to figure out, is the square root of 7. So 7 has to be somewhere between 4 and 9. Now to figure out where 7 would go, what I'm going to do is I want to figure out the midpoint of 4 and 9. I want to figure out what's in the middle of 4 and 9. So here's what I'm going to do. I'm going to do 9 take away 4 equals 5. And then to figure out the midpoint, so I know that the space between 4 and 9 is 5. Now to figure out the midpoint of those two, I'm going to do 9, or pardon me, I'm going to do 5 divided by 2 equals 2.5, which means if I add 2.5 onto 4, I'm going to say that the midpoint of 4 and 9 is 6.5. So that means if I was going to place 7 on this number line, 7 would go right about here. So I'm going to place 7 on that number line. Now, I want to estimate the square root of 7. I'm going to use my knowledge of perfect squares to do this. So I'm going to do square root of 4 is 2. And the square root of 9 is 3. That means the square root of 7 must fall somewhere in between 2 and 3. Well, if 6.5 is the midpoint of 4 and 9, then I would say the square root of 6.5 has to be about 2.5. So then I would say the square root of 7 would be about 2.5 or maybe 2.6. So if I was then to estimate the square root of 7, I would say, and I'm going to use a different symbol for this, I'm going to use these squiggly lines, which means approximately. The square root of 7 is approximately 2.6. And if you were to check that with your calculator, if you were to go and check the square root of 7 with your calculator, you would get the square root of 7 is approximately 2.6. In fact, when I use my calculator to figure this out, the square root of 7 comes up to about 2.64579913. So an estimate of 2.6 is very good. So that means if I'm thinking of the side length of a square that has an area of 7, the length of that side length of that square is approximately 2.6 meters. Now, it's not an exact square root because this number right here is not a perfect square. So what we're going to be doing in this section is we're going to be estimating square roots using a number line and using our knowledge of perfect squares. Let's do another question that's not a word problem, but we're going to do another square root estimate. I'm going to flip forward. So in this next question, we're going to estimate the square root of 18. And what I want to do first is go over to the perfect square page. Now what you'll see here is 18 is not a perfect square. The perfect squares are 1, 4, 9, 16, 25, but look, 18 isn't there, right? 18 is not a perfect square, so we're going to have to estimate its square root. Now this will be really important. 18 is going to fall between the perfect squares 16 and 25. Let's remember that for later. So what I'm going to do in this problem is I'm going to do the same thing I did in the first one. I'm going to make a number line. At the top of that number line, I'm going to do squares. And on the bottom of the number line, I'm going to do square roots. Now what I'm going to do on this number line, since 18 is not a perfect square, I'm going to put the perfect square that's below 18 on one side of the number line, And the first perfect square below 18 is 16. So I'm going to put that right there. And then I'm going to put the perfect square that's above 18 on the other side of the number line, which is right over here. Perfect square above 18 is 25. Where did I get those from? Right back here. (16) and 25 are the two perfect squares that would surround 18, right? 18 would be right in between those two perfect squares. But 18 is not a perfect square. So what I want to do next is I want to figure out where to put 18 on this number line. Now I know that it's probably going to be somewhere closer to 16, but I think it'll be easier to pinpoint if I find the midpoint of 16 and 25. Here's how I find the midpoint. I'm going to find the space between 16 and 25. Well, 25 minus 16 is equal to 9. And then to figure out the midpoint, I'm going to do 9 divided by 2, or cut 9 in half. 9 is 4.5. 9 divided by 2 is 4.5. So if I add 4.5 onto 16, I'm going to get the midpoint of this number line. The midpoint of this number line is 20.5. Now I want to estimate the square root of 18. So I now have a pretty good idea where 18 will fall on this number line. 18 will fall right there. Now remember, all the numbers we're putting on top here are squares. What I want to estimate is the square root. And I'm going to use my knowledge of perfect squares now to do this. So what I'm going to do first is do the square root of 16, and the square root of 16 is 4. And then I'm going to do the square root of 25. The square root of 25 is 5. That means the midpoint square root, the square root of 20.5, is going to have to be 4.5, right? Because that would be the midpoint of 4 and 5. Now, I have a pretty good knowledge to estimate the square root of 18. The square root of 18 has to be somewhere between 4 and 4.5. Now, I'm going to say 18 is right almost in between 4 and 4.5, so I'm going to say the square root of 18 is approximately 4.2 or 4.3. So I will say approximately 4.2. Now, when I put that number into my calculator, I get the approximate square root is 4.2640687. So we just round that to 4.2. The reason the square root of 18 is not a whole exact number is because 18 is not a perfect square. So we have just estimated the square root of 18, and the square root of 18 is approximately 4.2. On my next video, I'm going to do some more examples of estimating square roots. Flexing Teacher Weber, out.